Okay guys, here I go again. Okay, here's our question. We have Heppes buffer with a total concentration of 100 millimolar. The pKa of Heppes buffer is 7.55. And our question is, what is the ratio of the concentration of A minus to HA at pH 8.1? And what is the individual concentrations of HA and A minus at pH 8.1? Okay, I'm going to go ahead and do this again. I once again recorded it without sound. So we have Heppes, pKa 7.55, 100 millimolar at pH 8.1. So notice that the pH is greater than the pKa, right? 8.1 is greater than 7.55. So we know in the end we should wind up with a concentration of of A minus, the conjugate base, that is greater than the concentration of the weak acid. So our link between pH and acid-base ratios is Henderson-Hasselbalch. pH equals pKa plus the log, and I'm going to just leave out the brackets to make it easy, of the ratio of A minus to HA. 8.1 equals 7.55 plus the log, and I'm just going to call that ratio X, just to make it simple. Subtract 7.55 from each side. That is 0 plus the log of X, and that is equal to 2.55. If I raise both sides, this goes away. If I raise both sides of the equation to the power of 10, 10 to the 0.55 is equal to 10 to the log of X. Raising something to the power of 10 and taking its log are inverse functions, and so that just gives you X. That's the part that probably you wouldn't remember unless you've been using it recently. And 10 to the 0.55 is 3.54, or 3.55 is equal to X. That is our ratio of A minus to HA. And that is the first part of the question. The next part is, what are the individual concentrations of A minus and HA? Because if you're making a buffer, you want to know how much to add of each. Typically, you would have a stock bottle of Heppes base and Heppes acid. And so we can rewrite this. 3.55 is equal to A minus over HA. And if we multiply both sides by HA, we get HA times 3.55 is equal to the concentration of A minus. Now we know also HA plus A minus equals 100 millimolar. And that was a given. Way up here, I said that my total concentration is this. If you're given the concentration of a buffer, and they don't specify components, we assume it's both weak acid and conjugate base added together. And so I am going to take this, because it's the same thing as A minus, and put it in there. So I have HA plus 3.55 HA equals 100 millimolar. 4.55 HA equals 100 millimolar. Then I'm going to divide both sides by 4.55 to get the concentration of HA. So 100 divided by 4.55 is roughly 22. Concentration of HA is equal to 22 millimolar. We know that they both add up to 100, so 100 millimolar minus 22 millimolar gives us 78 millimolar, and that will be the concentration of A minus.